No, I didn't.
So we're back with special triangles. We've got 60, 30, 90 that we're going to learn about. We just did 45, 45, 90. Our example is always with the hypotenuse equaling 1 because that just makes things nice and neat. But of course, if the hypotenuse was 3, it would just be this thing times 3 as well, which would be 3 root 2 over 2. You just do the math, right? Proportions, ratios, that sort of thing. So for 60, 30, 90, we're also going to have our hypotenuse being 1. We know this is our hypotenuse because it's across from the 90-degree angle, which means it's the biggest side. What's cool about 60, 30, 90 is that when the hypotenuse is 1, the side opposite the 30 degrees is half. Half, okay? It always is. 1, this is a half. Which means that if this was 2, this would be 1, because that's half of the hypotenuse. If this was 3, it would be 3 over 2. 3 halves. If this was 10, this would be 5. There's a relationship there. 60 is a weird one. Now, you can either memorize this, or you can now do Pythagorean theorem, because we have 2 out of the 3 sides. For the longest time, I didn't memorize this. Memorization should happen on accident, like you do it so much that, oh, well, I can cut corners. Don't try to memorize, okay? So what I do is I say, well, we'll call this side C, because it's our hypotenuse, right? And that means 1 squared equals, we'll call that one A, because why not? We can call it B. And really, it's just a half squared. And then B squared is what we're trying to find. We'll label that B. I labeled that myself, right? The problem to give me it, I just did it because that's what works for me. So now we've got this. We can simplify. A half squared is the same thing as a quarter. Why? Because in fractions, the square applies to both numbers. So the top number squared, 1 squared is 1. Division sign, fraction bar, whatever you want to call it, same difference. 2 squared is 4. So a half squared is a quarter. That's all it is, okay? Could do that to it, you don't have to. I'm gonna live dangerously, okay? So we're left with this. I guess the B squared was already given to us. So we can leave that in black. 1 squared is just 1, right? That's the beauty of having 1 as your hypotenuse. So we've got this. Now we can simplify. To get B on its own, we need to subtract a quarter from both sides. So we'll subtract a quarter from here and a quarter from here. Well, a quarter minus a quarter is just 0, so we're left with nothing. If you don't get nothing there, then you didn't do algebra right, because you're running in circles. So now we've just got B squared here. We got rid of the quarter, and now we're left with this. 1 minus a quarter is 3 quarters, right? 4 quarters equals 1, right? 4 quarters in a dollar, that type of deal. Or you could just, you know, make that thing into 4 by putting 1 over 1 and saying multiply both by 4 over 4, and you get 4 over 4. It's kind of redundant, but 4 over 4 is the same thing as 1. I think we all get that, right? 4 divided by 4 is 1. That's all it's saying. And then when we subtract a quarter, we do this. Common denominators, good. Now we can do addition or subtraction. We're doing subtraction. We just subtract the top. 4 minus 1 is 3. 4 is coming along for the right. And that makes sense, right? You would never do, I guess, this equals, I don't know, that. If you have 5 quarters, right, literally like money, quarters, 5 quarters, and you have 2 more added to it, you wouldn't have 7/8. You'd have 7 quarters, right? Same deal here. The bottom number comes along for the right when we add or subtract. That's all that is. So over here we're left with 3 quarters. B squared equals 3 quarters. Now we got to figure out what B is, because we don't want B squared, we want regular old B. In order to do that, we need to do what? Square root both sides, right? Square root and a square cancel out, and we're left with B. And I told you this thing, when we have fractions and square roots, this is the same thing as this. 3, 4, both of them with a square root over the top of them. What does that simplify to? Let's do that up here. So we've got root 3 over root 4. Well, root 3, there's nothing you can do with it, right? 3 times 1, 3 is prime. Just got to leave it alone. Obviously, this is plus or minus, but we're talking about triangles, so just leave it positive. 4 squared, well, let's check that. It's not prime. Breaks into 2 and 2. Put them both inside. 1 gets out. We demolish the jail. It's just 2. So root 3 over 2 is B. Now you can memorize that when the hypotenuse is 1, B is root 3 over 2. Or you can do this and figure it out. If you ever are like questioning yourself, like, did I memorize that correctly or not? Do this and check. That's what's cool about math. If you want to memorize it, I would suggest memorizing it this way. Find your 30, the opposite of 30 first, right? It's half of whatever this is. That's pretty easy to do. Take that divided by half. 1 divided by 2 is 1 divided by 2, right? And then multiply it by root 3. So whatever you get here, times it by root 3. What I got there was 1/2, and I multiplied it by root 3. Root 3 is the same thing as root 3 over 1. When we multiply, we don't need common denominators, right? We can just go straight across. 1 times root 3 is root 3. 2 times 1 is 2. Aha, right? So it's root 3 times whatever this number is, the opposite of 30. Or you can do Pythagorean theorem and figure it out on your own. That's our special triangle there. If I were to change things around, like I were to change the hypotenuse and make this thing 6, what's the opposite of 30 going to be?
3.
3, because it's the hypotenuse divided by 2, right? Or you could write it like this, 6 divided by 2, which reduces to 3 over 1, which is just 3. What would our 60 side be, the opposite of 60?
3 root 2.
It's whatever this is, times what?
3 root 2. Or, no, it's...
Is it root 3 over 2 or just root 3?
Sorry, I skipped steps, but...
Exactly. So if you're not sure, Pythagorean theorem.
Yeah.
Otherwise, that's your answer. Remember before we had root 3 over 2?
Where'd you get root 3?
This is normally, when this is 1, this is root 3 over 2, right?
Mm-hmm.
So this would be a half. Again, let me draw a triangle over here. If this is 1, this is a half. The 60 side, this is 30, this is 60. The opposite of 60 is always root 3 times that, which is why we get root 3 over 2.
It's
So
not
when,
root 3 over 2,
exactly,
it's
this
root
is the mistake everyone makes. So don't memorize, know how to do Pythagorean theorem. If you want to memorize, that's cool, but do it at your own risk, okay? It's whatever this is times root 3, not whatever this is times root 3 over 2.
Okay.
So it's this times root 3, which is 3 times root 3. Ain't nobody got time for those decimals.
Times root.
Okay?
Root.
It's the 30 side times root 3.
So if the 3 right there
Let's do another example.
was 4, it would be 4 times root.
Your example, you're saying that the hypotenuse is 8, which means this is going to be 4, because it's half of the hypotenuse, the opposite of 30. Now to find the 60 side, we could either do Pythagorean theorem and do all that nonsense, or we could remember that whatever the 30 side is, we just multiply that by root 3.
Ha!
Ta-da!
Genius.
Now I'm going to throw a weird one at you. It's really not that weird.
Oh, no.
Oh, I get it. I get it.
No, what am I doing? Here's a triangle. I want you to find the sides. What is this going to be?
4.
4?
Yep, 4.
Yep, and then
2.
2.
This is our hypotenuse,
Yep.
which means this is our 30 side, which is half, which is 2. Oh, and then this is
Yep.
this side times root 3.
Yeah.
Ta-da! You did it! If you didn't know, you could have done trig, right? We can talk about that in a
That's
second.
a lot of work.
Or you could have reduced all this stuff to terms, and you could have matched stuff, right? You could have made a similar triangle, like this, and labeled that 1. And I said this thing was, what, 2 root 3?
Yeah.
So if this is 1, this is going to be, this is the 30 side, right? You know that's going to be half. And this is going to be just root 3 over 2, right? So how did I get from there to there? Well, you got to figure out the ratio. It's 1 to 4, right? 1 to 4. 1 to 4. Times that by 4 and you get 2. Times this by 4 and you get that, right? 4 root 3 over 2
Will there be a problem like that on the final
equals
where we have
2
to do the...
root 3.
Will there be like a ratio and we have to...
There
get
could be.
from-
I'm not saying there is. I don't remember.
Okay.
So that's our special triangles. Taking a break starting now.